Now let us find out unbalanced secondary forces and secondary couple. So we will use the same tabular column, space diagram is same. So this is a diagram for primary crank positions, and this is the secondary crank positions. So now how the secondary crank positions are written, so that is important. Earlier, so the angular position of the crank 1 with respect to horizontal is 0, then multiply it with 2, that is 0 into 2 is 0 only. That means, so cylinder crank of the cylinder 1 will come to the same position, 0. Next is second cylinder, crank of the second cylinder, so 0, that is, if you assume this as a reference, from here to here measured in the clockwise direction is 180 degree, measured in the clockwise direction is 180 degree, multiply it with 2, that becomes 360 degree. So 360 degree measured from this reference will come to the same position. That means crank of the secondary crank of the cylinder 2 will come to this position. Okay. So next is 3. So 3 is here. 3 is here. So the angular position of the crank 3 from 1 is 90 degree measured in the anti-clockwise direction. Measured in the anti-clockwise direction. That means you are measuring like this. Multiply it with 2 theta. It will become 180 degree measured in the anti-clockwise direction. With respect to 1, show it in the anti-clockwise direction by an angle of 2 theta. That means if it is 90 degree earlier, make it 180 degree into 2. That means 3 will come to this position. Now crank of the cylinder 3 will come to this position. Now 4. Earlier crank 4 was here, which was at an angle of 90 degree from 1. 90 degree from 1 measured in the clockwise direction. And multiply it with 2 theta. 90 into 2, 180 degree measured in the clockwise direction. If you want to show at this at 180 degree, so this 4 will come to this position. Now 4 has come to this position. You understood how this diagram is written. Now after this diagram, if you write this diagram properly, then rest of the things will be proper. Otherwise, if you do mistake here, everything will become wrong. So be careful while writing the secondary crank positions. Now after you write the secondary crank position, so we have to draw the secondary force polygon. So to draw the secondary force polygon, again you require a scale, because these values are same, we can keep the same scale. So earlier it was 0.3 kg meter is equal to 1 centimeter for primary force polygon. So I am keeping the same, 0.3 kg meter is equal to 1 centimeter. So now how to draw this force polygon? Now let us follow. So I already told it is not necessary to follow any one strand, any order. I mean 1, 2, 3, 4 like that. So here earlier in the previous case, that means while solving primary forces and couple, so we followed this order, 1, 4, 2, 3 order we follow. Now let us follow some other order. What is that order we are following? So we are going in this order. That means 1, 2 will draw first, 3, 4 in the order of 1, 2, 3, 4, same as the crank positions. With that, so let us start from any arbitrary point O. Let us start from any arbitrary point O. Now 1 is in this direction, because the centrifugal forces values are all positive. So we have to draw the centrifugal force vector in the directions of crank positions only. Now, so cylinder 1, crank 1 is shown 0.9 kg meter or 3 centimeter with respect to that, 0.9 kg meter in the direction of cylinder crank 1 of the cylinder 1. We are at point, say, A, we were at O, then we are at point A. Next, second, 2. So 2 is again 0.9, 2 is in this direction. Again draw 3 centimeter line in the direction of 2. Now we were at A, now we are at point B. Next, 3 is in this direction, opposite direction. Now we were at point B. Now show 0.9 meter, 0.9 kg meter in the direction of 3. That means we have to come back on the same straight line. We have to come back. Now we are at point, say, C. Next is 4. 4 is in this direction. Now 4 is not shown here. It is shown here. So 4 is shown in the direction of 4. Same magnitude. That means because all the vectors magnitudes are same, so we reach at the same point where we started. So what is the meaning here? Couple polygon is closed. It is not a polygon here, it is a straight line. But so the first point and last point are meeting at the same point. The meaning is that polygon is closed. The polygon is closed. What is the meaning? There are no unbalanced secondary forces. So secondary unbalanced force is 0. Now let us draw secondary couple polygon. Couple polygon. To draw secondary couple polygon, we have to use these values and we have to use these positions. Now which order we will follow? The same order. 1, 2, 3, 4 only we will follow. Now let us start from arbitrary point, say O dash. 1, the couple of the cylinder 1 is minus 0.25. 1 is in this direction now. Because it is negative, let us show in the opposite direction of 1. Start from O, come to draw O dash A dash in the opposite direction of 1 equal to a value of 0.2025, equal to this value. Take some suitable scale, calculate the required distance for the vector and draw equivalent vector O dash A dash. Next, which one will follow? The same, 2 we will follow. So what is the value of 2? It is minus 0.0675. Show it in the opposite direction of the crank position of the second crank position. That means in this direction only. We were at point A dash. So draw A dash B dash in the opposite direction of 2 equal to a value of this 0.0675. Next, which one will follow? 3. We are going the order 1, 2, 3, 4 like that. So 3 is positive. The couple due to cylinder 3 is positive. So in the direction of 3, in the direction of crank 3. So in the direction of crank 3 is in this direction. So now draw B dash C dash in the direction of 3 equivalent to value equivalent to this. Next, the fourth one, the value corresponds to fourth cylinder is positive 0.2025. So because it is positive, show in the direction of 4. 4 is in this direction, so in the direction of 4. Where it is, show in the direction of, earlier it was C dash, now we are at point D dash. Now we started from the point O dash, we are ending at the point D dash. So now it is not closed, polygon is not closed. We started from here, we are at this point. Now what is the unbalanced residual force? How do you close the polygon? If you draw one line downwards and if you go back and join, so you'll close the polygon. Though it is a line, but we are representing it in the form of a polygon. Now closing side of the polygon must be equal to a distance of O dash D dash. Measure the distance of O dash D dash. So that will give you unbalanced secondary couple. Unbalanced secondary couple, that is equal to M or L value you will get. Now from this, the calculated value, for example, if you get 10 centimeter you will get after measurement, then you cannot write 10 here. So 10 multiplied by the scale whatever you have taken. That should be multiplied with the actual distance, so that you will get this 0.54 kg meter square. This 0.54 kg meter square should be multiplied by omega square by n. Why we have to multiply it with omega square by n? So please recall, so what is the equation for the unbalanced secondary couple? Let us write first the unbalanced secondary force. The equation for the unbalanced secondary force is equal to m omega square r cos 2 theta by n. This is the equation for the unbalanced secondary force. If you want unbalanced secondary couple, so you will Fs into L, force into distance, will be the couple. Now what we have calculated from this diagram is the product of, let me multiply these two, which is equal to m omega square r L cos 2 theta by n will be the equation for the couple. Now this vector is already taken care of these values, m RL cos 2 theta, where we have considered 2 theta, cos 2 theta, because we rotated the crank by an angle of 2 theta, no? So there itself we have considered is to the cos 2 theta into consideration. Now what is not considered is omega square by n, which is not considered. Now this value will give you m or L cos 2 theta. So this value is equal to this 0.54. That is multiplied by omega square by n. Omega is the angular velocity, n is L by R ratio. So omega square L by R ratio, length of the connecting rod to the radius of the crank. If you simplify, you will get unbalanced secondary couple of 4798 Newton meter. So this completes the solution.